C program for implementing the circular queue. These are standard header files in C. stdio.h is for standard input output and stdlib.h is for memory allocation, malloc, free, etc. This line defines the maximum size of the circular queue. Write a structure to represent a circular queue. It's an array to store the elements of the queue. Max size represents the maximum capacity of the circular queue. It's an integer representing the index of the front element in the circular queue, and it's an integer representing the index of the rear element in the circular queue. A circular queue is a data structure that behaves like a queue, but instead of removing the elements, it overrides them. When the array reaches the end of the array, it wraps around to the beginning of the array, making the circular queue. This allows for the efficient use of memory since the elements are overwritten rather than leaving the gaps as in the regular queue. After structure, now let's write a function to create a new circular queue. It allocates memory for a new circular queue using the malloc function. It allocates memory for a structure type circular queue. The size of the struct circular queue calculates the size needed for the structure in bytes. It initializes both front and rear to -1, indicating that the circular queue is empty. Finally, it returns the pointer to the newly created circular queue. Now write the function to check if the queue is full. It checks two conditions to determine the circular queue is full. In first condition, if the front of the queue is at the beginning of the array, that is 0, and the rear of the queue is at the end of the array, max size -1, then the queue is full. This condition is used when the front of the queue is not at the beginning of the array. If any of the conditions are met, the function returns 1, indicating that the queue is full. Otherwise, it returns 0, indicating that the queue is not full. Now let us write a function to check if the queue is empty. If the front of the queue is equal to -1, it means the queue is empty because front is set to -1 when the queue is empty. When the front of the queue is not -1, it means that there is at least one element in the queue. The function returns 1 if the queue is empty and 0 if it is not empty. Now write the function to add an element to the queue. It first checks if the queue is full by using the isFull function. If the queue is full, it prints a message and returns without adding any element. If the queue is not full, it checks if the queue is empty using isEmpty function. If the queue is empty, it sets both front and rear of the queue to 0. If the queue is not empty, it updates the rear index by incrementing it using rear plus 1% max size, which allows for a circular wrapping around the array. Finally, it adds an element value to the queue at the rear index and prints a message indicating that the element has been enqueued. Now write the function to remove the element from the queue. It first checks if the queue is empty by using the function isEmpty. If the queue is empty, it prints a message and returns -1 indicating that the queue is empty. If the queue is not empty, it checks if the front of the queue is equal to the rear of the queue. This condition indicates that there is only one element in the queue. If there is only one element in the queue, it removes that element, sets both front and rear to -1 and returns the removed element. If there is more than one element in the queue, it removes the element at the front of the queue, updates the front by increment it using the front plus 1% max size, and returns the removed element. This also allows for circular wrapping around the array. Finally, it returns the removed element. Now write a function to display the elements of the queue. It first checks if the queue is empty by using the function isEmpty. If the queue is empty, it prints a message and returns without displaying any elements. If the queue is not empty, it iterates through the elements of the queue and prints them. If the rear of the queue is greater than the front of the queue, it means that the elements of the queue are contiguous in memory and can be printed in a single loop. If the rear of the queue is less than the front of the queue, it means that the elements of the queue wrap around the end of the array. In this case, it prints the element front of the queue to the end of the array first, then from the beginning of the array of the rear, then from the beginning of the array to the rear. Finally, it prints a new line character to end the output. Now let's write this main function to demonstrate the usage of the circular queue data structure by adding, removing, and displaying elements. It first creates a new circular queue using the createQueue function. Then it adds elements 1 to 5 to the queue using the enqueue function. It then displays the elements of the queue using the display function. After that, it dequeues two elements from the queue and displays the dequeued elements. Next, it displays the elements of the queue again to show the updated queue after dequeuing. Finally, it adds elements 7 and 8 to the queue and displays the elements of the queue again to show the updated queue. Here is the output of the program. 1 to 5 elements are enqueued. The message is printed as the queue is full and it will display the queue elements. Now it will dequeue and display the dequeued element. After dequeuing, it will display the remaining elements of the queue, after which 7 and 8 are enqueued to the queue. Finally, it prints the elements in the queue. In the next video, you will study about the double-ended queue.